Hi everybody, in this video we are going to talk about surface area. To find the surface area of a three-dimensional object, just add the areas of all the surfaces. Let's do some examples. Over here we have a square-based pyramid. The base is a square, all of the other sides, all of the other surfaces are triangles. So if we wanted to find the surface area of this pyramid, we would just find the area of each surface and then add them all up. So let's start with the base. We know that this side is 6 inches long, which means that this side would also be 6 inches long since it is a square. All sides are the same. So the area of the base would just be 6 times 6 because that's how you find the area of a square. You just multiply if we called this the length and the width, just multiply them together, and they're the same in the case of a square. So the base is just, area of the base is just 6 inches times 6 inches, which is 36 square inches. Okay, now let's focus on one of the side surfaces of this, one of the lateral surfaces of this pyramid. So we see that this is a triangle over here, and let's figure out the area of this triangle. The base of the triangle, and I'm not talking about the base of the whole pyramid, but the base of this triangle is 6 inches. So for the triangle, we know that the base is 6. Now, first of all, what's the formula for the area of a triangle? It's base times height divided by 2. The base of the triangle is 6. The height of the triangle, I'm not talking about the height of the pyramid, just the height of this triangle here is 10 inches. So we need to do 6 times 10 and then divide it by 2. 6 times 10 is 60, divided by 2 would be 30. Now, since this is a square-based pyramid, all of these lateral surfaces would be the same. So all 4 of these triangles have an area of 30 square inches. So in order to find the surface area of the pyramid, we would need to do 36 square inches plus 4 times 30 square inches, because there are 4 triangles which each have an area of 30 square inches. So 4 times 30 is 120. Remember your order of operations. We're going to do multiplication before we do addition. And then 36 plus 120 would be 156. All right, remember when you're adding, then the units don't change. So 36 square inches plus 120 square inches would not be 156 inches to the 4th power. Sometimes students will add the exponents together. You should not do that. Just keep them the same. So the final answer for this problem is 156 square inches. Let's move on to the next problem, which is a rectangular prism. And I'm going to show you here a couple of formulas you can use to find the surface area of a rectangular prism. But before we use these, let's actually just do it together, just by looking at it and thinking about it. So let's start out by finding the area of the front surface. Ooh. If this were kindergarten, I would fail because I'm not coloring inside the lines. But anyway, so let's find the area of this surface. Since it is a rectangle, all we need to do to find the area is 8 times 5. This is 8 centimeters. This is 5 centimeters. So for the front, we have, 8 centimeters times 5 centimeters, which is 40 square centimeters. For the right side, let's do that next. That would be 10. This is 10. And then this over here is the same as this over here, which is 8. So we need to do 10 centimeters times 8 centimeters, or 8 times 10. The order wouldn't matter. We get 80 square centimeters. And let's do the top next. All right, so this side is the same as this side, which is 5 centimeters. And this side is the same as this side, which is 10 centimeters. So that would give us 50 square centimeters. All right, now it might look to you like we got all the sides or all the surfaces already, but we didn't. Because the front surface is the same as the back surface, even though you can't really see it. Imagine you were Superman, you had X-ray vision. Then the back surface would be over here, and it would have the same area as the front surface. So the back would also be 40 square centimeters, just like the front. Okay, and again, put your Superman glasses on. Wait, does Superman need glasses? Never mind. Forget I said that. But anyway, this side over here, which you couldn't really see, but if you had X-ray vision, then you could see it. This surface, I sometimes mix the words side and surface. I should be saying surface. This surface is the same as this surface over here. So the left surface is the same as the right surface. So this should have an area of 80 square centimeters, just like the right surface. And then which surface did we miss? We missed the bottom surface. Put your X-ray vision glasses back on. The bottom is the same as the top, so that should have an area of 50 square centimeters. Oh, I forgot to write all that. Okay, this was the left, which was 80 square centimeters, and this was the bottom, which was 50 square centimeters. Okay, so to find the surface area, we would just add all of these up. Let's see. Let's see if we can do this in an easy way. So 50 plus 50 is 100. So we have 100. And then 40 plus 40 is 80. So now we're up to 180. And then another 80 would be 260, and then another 80 would be 340. Okay, so the total surface area, I ran out of space here, so I'll just write it over here, would be 340 square centimeters, just adding all of those up. Okay, so hopefully that wasn't too difficult. But now let's take a look at these formulas over here. How could we have used these to find the answer also? Well, the L means length, and really it doesn't matter what you call the length, what you call the width, what you call the height. But let's just say that this is the length over here. So the length is 10, the width is 5, and the height is 8. Okay? So it would be 2 times the length times the width, so 10 times 8, plus the width times the height, so 5 times 8, plus the height times the length, so 8 times 10. All right, so we have 2 times, 10 times 8 is 80, 5 times 8 is 40, 8 times 10 is, wait, I must have made a mistake here. The length times the width, 10 times, oh, that should be a 5. I'm sorry. So that's 50. Okay, so sorry about that. So this was the length times the width. Length 10 times 5 is 50. Okay, hopefully you recognize what these numbers are. This 50 is the area of the top, of both the top and the bottom. Each would have an area of 50 square centimeters. All right, this 40 over here, which was the 5 times 8, that's the area of the front, and it's also the area of the back. And then 80, which was the height times the length, that's the area of the right surface, but it's also the area of the left surface. If we just added all of these together without multiplying by 2, then we would get, let's see, 90 plus 80, which is 170. And that would be square centimeters. But that's like only adding the right surface and the front surface and the top surface, and forgetting about the bottom surface and the left surface and the back surface. It's like we lost our X-ray glasses and we forgot to look at those surfaces. So this is actually only half of the full surface area. We have to multiply this by 2 because there's sort of a duplicate surface for each of these. The right is the same as the left, the top is the same as the bottom, the front is the same as the back. So we need to multiply this by 2, and that would give us the 340 square centimeters that we saw before. All right, hopefully that's not too tough. You could also use this formula if you want, which is very similar. If you just distribute this 2 to each of these, then you get this formula right over here. So instead of adding all of these up and then multiplying by 2, it would look like this. All right, and hopefully this formula also makes sense to you because you remember there are 2 surfaces which are 50 square centimeters, and there are 2 surfaces which are 40 square centimeters, and there are 2 surfaces which are 80 square centimeters. So you have to multiply all of these by 2 before you add them, or like we did before, you could add them and then multiply by 2. Either way, it's the same. This would give us 100 plus 80 plus 160, and so 180 plus 160 would be 340, okay? And that would be square centimeters. So same answer that we got before. Let's move on to the last problem we're going to do in this video, which is a cylinder. Whoops. Okay, this is the cylinder. We could use these formulas over here, but first let's look at it and understand what we're doing, and then we'll look at the formulas. So what we need to do to find the surface area is we need to find the area of the top and then double it because the top is the same as the bottom. And then we have to find the area all around it as well. Imagine that I'm sort of painting the front and then going around and painting all around this thing, okay? So that's what we need to accomplish. Let's start out by first finding the area of the top over here. So we're told that the radius is 4 inches. So how do we find the area of a circle if we know the radius? It's just pi r squared. And just to simplify things a little bit, let's use 3.14 for pi. So that's an approximation for pi, which is very common. 3.14 times 4 squared. Again, let's remember our order of operations. We would do exponents before doing multiplication. So 4 squared means 4 times 4, which is 16. So we need to do 3.14 times 16. Let's just use a simple calculator for that. 50.24. And that would be square inches. Okay, because the 3.14 is dimensionless. Then this 4 was really 4 inches. So if we do inches times inches again, since we're squaring it, we would get square inches. Okay, so that is the area of the top. I'll just draw an arrow there. It's also the area of the bottom. Okay, now what about the area all the way around? Well, imagine that you had the cylinder, okay, which looks like this, all right? Imagine just cutting it and then unraveling it. What shape would you get? You would get a rectangle. And hopefully you would agree that the area of the rectangle is the same as the area of the lateral. Oh my gosh. Hopefully you agree that the area of the rectangle is the same as the area of the lateral surface of the cylinder. When we cut the cylinder and we unraveled it, we weren't changing the amount of space that's here. Okay, so all we need to do to find the area of the lateral surface is to find the area of this rectangle, because they're the same. Now, we know what the height of the rectangle is. That would be the same as what's written right over here. Okay, if the height of the cylinder was 9 inches, then the height would not change when we unravel it. Okay, the height of the cylinder from here to here, that's not going to change when we unravel it. So the height is still 9 inches. What would the length of the rectangle be? Well, the length of the rectangle, let's re-ravel this. I don't know if that's really a word or I made it up. The length of the rectangle is the same as the circumference of the circle. Again, the length of the rectangle is the same as the circumference of the circle. So we need to figure out what the circumference of this circle is. And we already know that the radius is 4 inches. So to find the circumference, we need to use the formula for the circumference of a circle. Remember, the circumference of a circle is equal to 2 pi r. Don't get that confused with the area of a circle, which is pi r squared. The circumference of the circle is 2 pi r. So let's plug in 4 for the radius, and we'll also use 3.14 for pi. So we're going to do 2 times 3.14 times 4. So 2 times 3.14 is 6.28, and then 6.28 times 4 would give us 25.12, and that would also be square inches. Oh, no, I'm sorry. No, it wouldn't. No, we're talking about circumference, which is one-dimensional, so that would just be inches. I'm sorry about that. Okay, but then when we multiply it by the height, then we would get square inches. So what we just figured out is the circumference of this circle, which is the same as the length of the rectangle. Now we need to multiply that by the height of the cylinder, which is like the height of the rectangle. So the next thing to do is 25.12 inches times 9 inches, because all you have to do to find the area of a rectangle is do the length times the height. All right, and let's just use a simple calculator for that. So 25.12 times 9 is equal to 226.08. All right. And that would be square inches. All right, so we know the area of the top, we know the area of the bottom, we know the area of the lateral surface. Now we need to add everything up. So we have 50 plus 24 plus another 50.24 plus 226.08. These are all square inches, and when you add them all up, then the units are still square inches. So 226.08 plus 50.24 plus another 50.24. 326.56. Okay, square inches. So that is our final answer for the surface area of this cylinder. Now let's go back to these formulas over here, which are equivalent to each other. We have pi r squared times 2. Where does that come from? It comes from the fact that to find the area of the top, we have to do pi r squared, but then we know that the top is the same as the bottom, so we have 2 of these. So it would be 2 times pi r squared. So this term in the formula is telling us what this and this are put together. Okay, then we also have plus 2 pi r L. Now, where does that 2 pi r L come from? Well, the 2 pi r is the circumference of the circle. The L is the length from here to here. So that's what I've been calling the height this whole time. Maybe H would have been a better letter for me to use, but it really doesn't matter what you call it. So we're taking the circumference of the circle, and then we're multiplying it by the height of the cylinder. That gives us the area of the lateral surface, which was the same as the rectangle. Remember? So this is the area of the lateral surface. So when you add the areas of the two bases here, the two circles, to the area of the lateral surface, that gives you the area of the entire cylinder. Now, where does this come from? Well, notice that both of these terms have 2 pi r in them. So you can factor that out and simplify the expression a little bit. If you factor out the 2 pi r, then what's left is an extra r over here, because remember, r to the second power really means r times r. So there are 2 r's over here. So that's where this r comes from. And then there's also an L over here. So factoring is just distribution in reverse. So if that seemed a little bit confusing to you, then to check that, you could just distribute here. 2 pi r times r is 2 pi r squared, because we have r times r, that would give us r squared, plus 2 pi r times L is 2 pi r L. Okay, so this is really the same as this. Let's just go ahead and practice using this formula over here to see that it really does give us the same answer. I really wish I had called this H before, because that's what I've been using the word height this whole time, but whatever. So just when I say L over here, I really mean the height over here. So we have 2 times 3.14 times the radius. R stands for the radius, so that was 4, And then in parentheses, we have another r, so that would be another 4 over here, plus the height 9. Okay, so 4 plus 9 is 13. So we have 13 inside these parentheses, and that's getting multiplied by all this. So we have 2 times 3.14 times 4 times 13. Let's work all of that out. 2 times 3.14 times 4 times 13. Same answer that we got before, 326.56. And that would be square inches, because radius is in inches and the height is in inches. So inches plus inches is still units of inches. Then when we do inches times this other inches over here, and we get square inches. And pi and 2 are both dimensionless. All right, so that's it. I'm going to end the video there, and have a great day.